You're listening to Lab Out Loud, Science for the Classroom. I'm your co-host, Dale Basler.
And I'm Brian Bartel.
And you know, it is springtime. And springtime, I mean, I don't know where you're listening from, but springtime in northern part of the United States, in Wisconsin, means that everybody starts coming out of their house again. After the cold, after the snow, all of a sudden you start seeing your neighbors.
Oh, look, we have new neighbors.
Yeah, and they're walking around and all those kinds of things. And the same thing happens in the classroom. You start to have the opportunity to maybe have a class outside or even do a little science outside.
And I think obviously that we're lucky as science teachers because we can afford the opportunity to go outside to actually do science as a good excuse instead of just going outside when it's nice.
Oh, yeah. One of my colleagues has, we have a pond at the school that's right by us, the one I used to teach at. And he goes out there and does he's an environmental science teacher, and he can use that pond and the animals that are there. So you can be sort of the naturalist and take note of the animals around you or the plants and things like that. But you can take that a step farther with some, up digital level and collect data.
Yeah, we've actually talked about Vernier probes and sensors on the show before, and we're going to again today. And what really caught our ear on this, did you see what I did there?
Yeah.
Or did you hear what I did there? Oh,
yes,
I should have kept with the pun. Okay. In any case, thinking about using Vernier sensors in the classroom, this science teacher that we're going to talk to, Brian Kaestner down in San Antonio, Texas, shows us how his students use sensors to measure things locally as a way to describe things that are happening on a global scale. And I think that's a novel approach when we sometimes think about climate change is such a big thing, and how can you measure ocean currents and sea levels and temperatures across the world? But his argument is tackle this locally as a way to discuss it globally.
Yeah, it really gives students something to grab a hold because, of course, they make that connection. Let's meet our guests. First up is
Colleen McDaniel.
I work at Vernier Science Education, where I am a biology and environmental science educational technology specialist.
And also joining us is
science teacher Brian Kaestner.
I teach AP Environmental Science. I'm down at St. Mary's Hall in San Antonio, and some other stray biology courses, help out with the women's soccer team, and then also I'm part of our outdoor education program.
Fantastic. Well, Dale and I are both big fans of Vernier. We've used Vernier for a long time in our careers as science teachers and educators. And we started back when they still had like serial ports and those BT, is it British Telecom like plugs? Is that right?
Yeah, there's BTAs, the British analog ones, and BTDs, the digital ones, depending on what type of sensor you're using.
Yeah, and we would never have thought about everything going wireless back, that was a millennia ago, basically, but that was when we started. In fact, it was kind of funny. This is just a little side note on my own career, but one of the first interviews I had as a science teacher was to be asked if I had any experience with using like basically probeware, and I didn't. I had come from a university that didn't have that, and so they passed me over. But I showed them, and I found a way to definitely incorporate it into my practice later on, and I feel like they lost out. But I'm happy where I am now, of course.
Yeah, the things going wireless has definitely changed education quite a bit, I would say.
Well, and for sometimes frustration in terms of connection, but also in terms of flexibility and what you can actually do with that kind of technology. So let's talk a little bit about that. I think in some ways here, we're kind of joking about 30 some years ago, and climate change had just kind of been getting started talking about in the classroom. But I don't think we would be thinking about finding a way to measure it in the classroom. But that's kind of what we're hearing that you're doing. Is that correct?
Yeah. So one of the things that I like to take approach when I was teaching, I used to teach AP Environmental Science in Texas, as kind of like Brian's doing now. And one of the things I used to touch a lot on with my students was it's hard to actually showed climate change actively happening, but in the classroom, but it's really easy to show the effects of it. And that's where a lot of the sensors are coming in useful to show how climate change can have different effects on different ecosystems.
We try to take a very local to regional to global approach with that. And I found that's more effective with students, but also that's so much easier to measure even on your campus, that if they get the concepts of what's happening campus-wide, then you can expand that to a more global approach. And we do simple things like doing urban heat island, but what's the heat island of your campus? What parts of the campus are cooling and heating differentially, and really try to look at the temperature piece on campus so we can extrapolate that out.
So you've done some of that, it sounds like, with your classes there, Brian. And I guess, what were some of those? Did you have any eye-opening moments from students, or what were some of the results that surprised you even?
Well, I think the biggest piece is for any campus that has a plastic field, you get a noticeable change in the temperature. That any athletes who use the field are well aware of the differences in the heating and cooling of plastic versus a grass field. So that sent us into looking at grassy areas on campus, asphalt, concrete, the plastic, areas where we've got good canopy cover, and even rooftop surfaces, and just looking at the whole idea of differential heating cooling rates, and then being able to look at that on the whole campus and then expand that out to the city. But I think the plastic field piece was even surprising to me, how hot it gets during a sunny day, particularly in Texas.
I guess I never thought about that. And of course, a soccer coach, you're a little bit more, I guess, close to that field.
Well, fortunately, soccer in Texas is in the winter, or what we call winter here. But for lacrosse and football that are in spring and fall, the temperature differences are some that we are a safety concern, but also allow us to look at the picture of what's happening on campus, then what's happening in San Antonio, and then what's happening regionally and globally.
So did you have any students that wanted to branch out from those experiments on campus and take it somewhere local? Just, hey, I'm going to take this over the weekend and do some measurements, or and again, any surprises or shocks there?
Well, the first thing they did actually was go into Google Earth Pro and map out all the surfaces on campus.
Oh, okay.
So Google Earth Pro lets you do irregular shapes. So they actually did map out concrete surfaces, asphalt surfaces, grass surfaces, plastic, rooftops, and looked at the percentage of those surfaces on campus, which of course goes also into the direction of biodiversity studies on campus. But that's kind of the first thing they did, to look at that, and then look at the temperature pieces and analyze how much something that's 15% of the campus, but is having an inordinately large impact on campus temperatures. And then they started to look at that in San Antonio urban areas.
Okay.
What they found out is I had no idea, but what they found was that when they looked, I forget where they searched for canopy cover of urban areas, and San Antonio actually has a fairly large canopy cover compared to other cities, which led us into energy and heating. Well, we don't really do a lot of heating costs. Most of our electrical costs is for cooling. What's the economic impact of canopy cover, of how much asphalt you have, how much concrete you have? And although that's not a direct correlation necessarily with global climate change due to CO2 amounts. Those changes in temperature, no matter what the cause, have a direct economic impact. And of course, we know a wide variety of other impacts that students need to start looking at. So it kind of did lead us astray in some good directions.
I like thinking about that. Yeah, that's good to hear. What kind of sensors were you using in this scenario?
The temperature sensors are easy to use for this. I saw, Colleen, that there was a new surface temperature sensor.
Yes, the surface temperature is the one I like the most because it doesn't have the stainless steel cover on it, so it actually responds even faster to temperature changes, which is really nice. And then you can actually even put it on different surfaces, and it can actually be put in water as well to measure kind of surface temperature changes really easily.
Because I haven't seen that one, and I'd like to try that one because we use the stainless steel ones, and we've also used infrared thermometers to do surface temperatures. But I like the idea of if we just take that sensor and lay it on the surface.
Yep. Yeah, that's one of the reasons I like it the most is because it's just a thermistor just sitting out there in the open. It changes so much faster and gets to the actual reading a lot quicker than the stainless steel temperature probe does.
Has anybody? Go ahead. Sorry.
The infrared thermometers, are you using the ones where you just kind of, you can point in the
Point and
laser
shoot?
beam?
Yeah. Tease cats with?
I seem to get all kinds of results with those.
Well, that's why I wonder about the surface temperature one, the new one.
Yeah, because those little pointer ones, you really have to be conscious of the distance that you're shooting it at. And
so that was one of our controls that was an issue early on.
How do you tell students how to kind of navigate that?
Hopefully they figure it out. I'm being optimistic to say that they figure that out right away. But some of the times I'll just let them go through the first set of temperature readings, and they go out in their pairs or their groups. And then we come back and we talk about how they took the temperature. And of course, some will go, well, I held it at my waist, or I held it at my knee, or I put it 6 inches away from the surface, which is usually, at least as far as I'm concerned, a good opportunity for them to look at it and think about the experimental protocol and eliminating that variable. My tendency is to say, let them make that error the first time, because they'll all come back from around campus and nobody's communicated about how they're going to take the temperature.
Okay.
And then so they all come back, and then I ask them how they took the temperatures, and we end up doing it again. But I'm okay with that.
Memorable.
Next time they'll go, okay, how are we going to do this water sample? How are we going to take this sample? How are we going to do these counts? And I just find that so much, not necessarily easier, but better in terms of them talking about experimental protocols and reducing the number of variables before they go do the work. If I always tell them that, then I don't think they learn that as quickly. Maybe it doesn't sink in as well as if they have to go back and do it again. But that's an issue, and that's why I think Colleen's made a sale here that I'm going to need to order some of the surface temperature and try that, and maybe run it with both.
Yeah,
sure.
Run it with the
Get a good comparison
and run it with the IR.
You mentioned that you have different sensors here that you're using, especially for temperature. Are these the wireless ones that you're talking about?
I am shifting over all of our. We've been a Vernier school since the beginning. I was very fortunate to have a colleague, Carol Brown, got in on the Vernier chemistry side with the Verniers very early, and he quickly convinced me. And you were talking about the old BT stuff.
Yeah.
I have a feeling there's a box of those somewhere around in our storage room still.
Now they're like antiques.
And so,
Yeah, I started with graphical analysis on a Mac Classic.
Oh, wow. Original graphical analysis.
Yeah.
Yep, original graphical analysis. Yep.
we did the same. And so I've been on board for a long time with that, and have really tried to manage things to move the department in terms of getting as much of that over to the Go Direct as possible. And so I think as Vernier is putting out more and more Go Direct probes, we're moving towards those as they become available. And honestly, a part of that is the cost for a school to be able to go with the ProbeWare direct to students' phones is significant. Because for us, we're a small private school, and for us, one of the biggest expenses was buying the LabQuest. And so I think the availability piece for me when I'm working with instructors in the summer is a big piece of being able to use the Go Direct as much as possible. So we're getting there.
We'll be right back.
It's interesting because last year we were at our state science conference, and they have an equipment swap meet, and basically you bring in things that you're not using anymore, and you're free to take them, and it's kind of a wonderful thing. But there were at least 24 these Lab Pros that we used to use, those green plastic ones there, and they must have switched over to LabQuest or to Go Direct or something on that, and they're not using them anymore. So I picked up a couple just for Dale and myself, just because
I still think of those as new.
I still do too, because those were the upgrades from the old cereal box.
That was like going to HD when you switched to those from what we were using.
But,
I mean,
But I want you to talk a little bit about the wireless facet of it. And you said that students are using it with their phones. What kind of advantages are there to doing that? And are there disadvantages as well?
Yeah, the Go Direct is the wireless. So that's Go Direct's Vernier term for it, correct?
Right.
Tell us that connection. Is that Bluetooth? What are we looking at here?
Yeah, so the Go Direct line is nice because it is Bluetooth capable. But the reason we also call it just Go Direct is that if the device doesn't have Bluetooth, or the Bluetooth doesn't work that great, like what we see with a lot of Chromebooks, is you can connect it directly by USB as well. So it has this kind of dual functionality that it can go direct Bluetooth, and it's really easy on phones and things like that to go Bluetooth. But on Chromebooks or computers or things that have USB ports, being able to connect by USB is also lovely, because you don't have to have that like major, oh no, my Bluetooth isn't working troubleshooting problem. You can just connect it directly and you're good to go.
I'm looking at the surface temperature probe for the Go Direct one. I don't see a USB port on there. Is that a cord that plugs into it?
Yeah, so there is a USB micro that connects to the probe, and then it will connect to the computer by, USB, like the normal USB, or you can also get like USB-C version cables as well.
Now, were this kind of line of products, was this in response to kind of like the Chromebook market and those kinds of things where it was more necessary, or was it response to like new needs? I guess that is a new need, but was it strictly Chromebooks driving the ship here or not?
Well, originally the app that these work with, the new graphical analysis app, that originally was driven kind of by the Chromebook era, because our older software, Logger Pro, cannot work on non-computers basically. And so we developed this graphical analysis, and then we saw an advent of not just Chromebooks, but a lot of iPads going into the classroom too.
Sure.
And saw that by doing this Bluetooth method, it really opened up the door for a lot more versatility. really. And
Mm-hmm.
what Brian was saying with the price point is that it opened up a door where teachers didn't have to purchase a LabQuest or a solid interface anymore to be that bridge to connect sensors to. So it actually eliminated a lot of the cost that educators were finding to actually be able to introduce sensors into their classroom.
And that's been huge for us because we had the LabQuest 1s and then the LabQuest 2s. And then we did get one LabQuest 3, which I really like. It's beautiful. But I don't think we're going to buy any more of those. Sorry about Colleen.
That's okay. I understand. If I was in the same situation, I'd be doing the exact same thing.
Our funds are more spent on the probes as they come out, because I have an old set of UVA, UVB probes, which I love. They're a great set for students to learn experimental design with. But I'm also going to be really happy when they come out with the Go Direct Bluetooth connection. And so we do a good bit of water quality. We do a lot of soil analysis. I'm a soil person. And we also do a lot of water quality work on local waterways, Salado Creek. So being able to go in the field with the various chemistry probes for water quality, the Go Direct ones are, let's see, I think most of the chemistry ones, nitrate, ammonium chloride, calcium, are all Go Direct, plus temperature, pH. We do our DO that way. It's really easy to have the set of probes, and then student groups, pairs, threes, however you want to do it, can grab the probes, connect them to their phones, and then do different areas of the creek, do one of the ponds. We've got 2 ponds and 1 creek area that we work in that we do some comparative water quality work with. And that's, for us, that's just a quicker, easier, and less expensive way to do that kind of local water quality piece.
Mm-hmm. Do you find any problems with having students connect them to their own devices, or do they find that liberating, or they have no problem with it? Like, well, whatever.
It really, that's the case. It's just, they're so used to doing that now. I'm still reasonably good at solving the tech problems, but usually if I can't, one of them will. And if I can't get it and we can't get it, then I contact the folks at Vernier and they'll solve it. But for the most part, they can just, and at least, if I remember correctly, Colleen, you can connect 4 probes to 1 phone.
Yep. Yeah. Depending on the device, you can connect. I've been able to connect up to 6 sensors to my iPhone.
Okay.
At one time. So it allows you to do many, and then it gets a little busy at that point.
Sure.
Right. And the only downside of the Bluetooth is if I only had 1 optical DO Bluetooth sensor, I can't have a student use it and get it to everybody's phone, because that's not how Bluetooth works.
Right.
And so once in a while they'll go, why can't all 4 people in the group connect to that DO piece? It's the same reason why all 4 people can't connect to your earbuds.
Right.
That's not how
that's the exact explanation I give too. And that's where we do have feature and graphical analysis, that there is a pro version of that application that actually does let students share data from one device to multiple devices. So that's been our kind of way to work around the nature of Bluetooth, and that Bluetooth is one-to-one. By doing kind of data sharing through Graphical Analysis Pro, it allows the students to share the data they've collected with everybody else in their lab group.
And that's what we do. That works fine.
Does that like rebroadcast the information out? Is that how that works?
It uses basically a internet connection, essentially.
Okay.
And so like you open up a sharing ability in the app. And even if you had a student even at home who was sick and missing a lab, their lab group could actually stream that data over the internet to them, and they could get it live.
We haven't done that
experiment.
So, I mean, we got to be careful here, because I think one of the like hallmarks of being in Wisconsin and having a snow day is that you get the day off. But what you're suggesting is you might you're still learning at home, perhaps, in some of these situations.
You can just attach it to your shovel.
or sled.
Yeah, there you go.
See, it opens up the possibility for students to start experimenting at home more.
There you go. Colleen, we've been talking about some temperature probes, and I know Brian's mentioned a couple other things with water quality, dissolved oxygen, and whatnot. What other sensors are out there that you might use to measure climate change, or other sensors for the environment?
So one of the ones that I feel it's kind of the unsung hero of sensors is we have a light and color sensor that measures visible light and UV light as well. And I really like that, to use that sensor in combination with the temperature probe to look at basically the effect of reflection of light, or albedo, on different surfaces, and correlate that to temperature. So students can actually look at, so the grass field isn't as warm as the driveway, and then we can look at the reflection of light coming off of those and see how it differs between them, and try to find a correlation between that reflection and the temperature. And go ahead, Brian.
I haven't done that one. Can I combine that with doing surface temperature and the light and color, because that would add in to the local heat island effect. It would add in the albedo piece.
Yeah, and that's one of the ones I like to do a lot, because it's a great way to relate them. And then, because I know when I was teaching, trying to explain albedo to students and why, melting polar ice caps are reducing albedo of the poles, and they were having a really hard time understanding it. And I found kind of being able to show them how albedo works on different surfaces around where they're located really helps them kind of connect that and get that understanding of what that actually means and how it can affect climate.
I love that local to global connection. Have you used the pyrometer or the PAR sensor with any of that?
Yeah. So not so much the for the pyrometer that we have, that's going to be more for looking at solar cells and looking at how much how much light is available for a solar panel to be able to convert into solar energy. And then the PAR sensor, another light sensor, is specifically looking at wavelengths for photosynthesis. So
our botany people use that.
Yeah, that's a really popular one with botany. The other sensor I love for kind of climate studies and stuff is there is a weather sensor that we developed, basically came out right when COVID hit, of course. And
sure. It's like a little green, it's got like a little fan in it. Is that right?
Yeah, it's a nice little portable sensor that it basically, we were looking at developing, because what we do as we make our sensors go direct, we look at what sensors we have and how we can basically best make them in a wireless version. And we realized for cost efficiency, it was better for us to actually take an anemometer, humidity, and temperature probe and a barometer and put them all on one sensor instead of making 4 different sensors.
Yeah.
And so the weather sensor basically it's an anemometer, so you can get wind speed, and then there's temperature, humidity, and pressure. And you can we've created channels on those so that it can use those sensor measurements to then calculate things such as barometric pressure versus station pressure, looking at relative humidity, absolute humidity, and then also being able to, in some situations, look at wind chill and the heat index as well.
All right.
Is this the Go Direct weather system?
Yes, the GoDirect weather system. And the system comes with a weather vane because we actually have a magnetic field sensor in the sensor as well that will allow students to actually measure the direction of the wind based on the magnetic field.
Got it.
I love that one. I don't have that one yet, Colleen.
I'm making a wish list for you, Brian.
There you go.
That's okay.
Do you have any other sensors that are coming out, or something you're excited about coming into the, I guess, into the commercial space soon?
Yeah, so the biggest one, hopefully in the next few months, we're going to have a new GoDirect soil moisture sensor. That's been in the works for a while, and I'm really looking forward to this one because the nice thing with the GoDirect is we're also able to kind of make some of these sensors do more than just one thing. So now the soil sensor isn't just going to measure soil moisture, but it can also do soil temperature as well, which usually you're wanting to measure those hand in hand.
Right.
So it's kind of nice to have everything all in one instead of having to use multiple sensors. So that way you'll be able to get soil moisture and temperature all in one swoop.
Before we let you get going here, this is a lot of again, intriguing new technology that we can bring into the classroom and have students use on their own and with their own devices. If you were a teacher wanting to get started on this, where would you go? And do you have resources for lessons that people might need?
We have tons of resources available on our website at Vernier.com. The other thing I highly recommend people do is just to reach out and talk to us. You can call us, and we have a 888-837-437. And you can talk to anybody in my department. Our support department is here to answer any questions. We also have a live chat on our website during open hours.
It's like a real chat too, not one of those little fake chats.
It's like a real chat. Like you can click on it and be like, oh, hey, look, Colleen's available to talk to me right now. And then also just emailing us at support@vernier.com. And one of the things that I love about my job is getting to talk to teachers every single day, helping them with equipment, helping them choose what's going to work best for their classroom and their situation, to make sure that, because we know that teachers have limited funds, and we want to make sure that they're going to get equipment that they're actually going to get the most use out of. That's what's most important to us.
And the AP Environmental Science Investigation Manual from Vernier, like all of their other manuals, is excellent. And it's very investigation oriented. But I also try to remind any instructors who are teaching ecology, environmental science at any level, the labs that are in there will work. It doesn't have to necessarily be just for an AP course.
Yes.
Okay.
Oh, that's a good point.
Good to know.
Yeah, and that's one thing I love talking to teachers through, of how to modify different experiments to use sensors with them. And sometimes I am able to take those and write them up into a protocol and do some great experiments with them. For example, there was an idea to do a lab looking at ocean acidification. And I was able to figure out a way to do that with a pH sensor on basically a lab situation in the classroom, so that they can actually show students what happens with ocean acidification and the pH of salt water.
Interesting.
Well, thank you so much for your time. This is informative to see what's out there and how we're using sensors in the classroom and what the next level is.
Yeah. Well, thanks for having me.
Thanks for letting me join in.
Thanks for listening to our show. If you'd like to know more about this episode or any of our previous episodes, visit laboutloud.com. Lab Out Loud is produced by me, Dale Basler, and my co-host, Brian Bartell. If you have questions, comments, or suggestions for Lab Out Loud, visit laboutloud.com/contacts. Thanks again.